Hi guys, this is O-level chemistry paper 12, November 2016, question 1. When measured under the same conditions, which gas diffuses at the same rate as nitrogen? So if the conditions are kept the same, the only way for a gas to diffuse at the same rate as nitrogen is for it to have the same MR value as nitrogen. So for nitrogen, the MR is equal to 28 because we've got two atoms of nitrogen and the mass of a single atom is 14. So 14 times 2, 28. Now we need to find the MR of the given gases. So for ammonia, it would be 14 plus 3, which will give us an MR value of 17. For carbon monoxide, it would be 12 plus 16, which would give us an MR value of 28. For C2H6, we would get an MR value of 24 plus 6 equals 30. And for oxygen, the MR value would be 16 times 2 is 32. So since nitrogen has an MR of 28, the gas with the same MR is carbon monoxide. Therefore, carbon monoxide would diffuse at the same rate as nitrogen, making option B the correct option for this question. Question 2. When calcium carbonate is added to dilute hydrochloric acid, carbon dioxide gas is released. Three sets of apparatus are shown. Which set of apparatus are suitable together with a stopwatch for following the rate of this reaction? So in order to follow the rate of reaction, we need to time something. So in setup 1, we have a conical flask kept on a weighing balance. So we will time the decrease in the mass of the container because CO2 gas will be lost. In setup 2, we have collection of the carbon dioxide gas. So we can time the rate of collection of CO2 gas. In experiment 3, we've got a thistle funnel instead of a tap funnel, and we've got collection over water. Now, the problem is that CO2 is soluble in water. So not all of it would be collected in the measuring cylinder. So even if we follow the rate of reaction, the rate of collection of gas would not be correct since some of the carbon dioxide would dissolve in water. Therefore, setups 1 and 2 can be used to follow the rate of reaction. Setup 3 has an issue with CO2 dissolving in water. Therefore, the correct option for this question is option B. Question 3. Which statement is correct? Carbon monoxide reduces sodium oxide to sodium. Sodium oxide is not reacted with carbon monoxide at all. If we have to extract sodium, that would be done by electrolysis of sodium oxide. Next, during the electrolysis of copper to sulfate solution, hydrogen is liberated at the positive electrode. Positive electrode is the anode, and anode is where oxidation occurs. So we have oxygen gas producing at the anode. Hydrogen gas still will not be liberated at the negative electrode because copper is less reactive than hydrogen. So copper would be produced at the cathode. So hydrogen is not liberated during the electrolysis of copper to sulfate. Recycling aluminum conserves the Earth's finite supply of hematite. Hematite is an ore of iron, not of aluminum. Bauxite is the ore of aluminum, Al2O3. Iron oxide is reduced to iron in the blast furnace. Yes, the reaction is Fe2O3 reacting with 3 moles of carbon monoxide, producing 2 moles of iron and 3 moles of CO2. Therefore, option D is the correct option for this question. Question 4. Benzene and cyclohexane are both flammable liquids. They are able to mix with each other without separating into two layers. They have very similar boiling points. It is difficult to separate a mixture of these two liquids by fractional distillation. Why is it difficult to separate a mixture of benzene and cyclohexane by fractional distillation. They are both flammable. This has nothing to do with their separation. They are both liquids. This has nothing to do with separating them. They have very similar boiling points. Yes, liquids that have similar boiling points are difficult to separate using fractional distillation because both of them will boil almost at the same time and cannot be collected separately as a pure liquid, and they mix with each other completely. This has no effect on their separation because separation is brought about for liquids that are mixed with each other. So option C is the correct option for this question. Question 5. The graph gives a melting point of mixtures of lead and tin. On the left, we have the melting point of pure lead. On the right, we have melting point of pure tin. And in between, we have percentages of lead and tin that have been mixed together. Okay, so the graph shows that any mixture of lead and tin must have a melting point that is any mixture of lead and tin. So we have mixtures of lead and tin from 0 to 100%. 0% of tin going up till 100% of tin. So we have mixtures of lead and tin that have a boiling point or a melting point greater than tin itself. But we don't have any mixtures that have a melting point greater than that of lead. So the graph shows that any mixture of lead and tin must have a melting point that is above that of tin. No. Below that of lead? Yes, because all the mixtures have a melting point below that of lead. Below that of both tin and lead? No. Between that of tin and lead? No. So mixtures have any melting points that ranges from anywhere below the melting point of lead, and melting point of tin comes in between. There is no specific uh, use of the melting point of tin here because all of them have a melting point lesser than pure lead. Therefore, the correct option for this question is option B. Question 6. Which statement about chlorine atoms and chloride ions is correct? So, chlorine atoms and chloride ions, they have a proton number of 17 and a mass number of 35.5. Okay. They are both isotopes of chlorine. No, isotopes have the same number of electrons and protons, but different number of neutrons. Here, the number of electrons are different in both of these species of chlorine. They undergo the same chemical reactions. No, they do not undergo the same chemical reaction. Chloride ions are oxidized to chlorine. Chlorine atoms are reduced to chloride ions. They have the same number of protons. Yes, S can be seen by their proton number, which is 17 for both. They have the same number of protons. And they have the same physical properties. No, they do not have the same physical properties. Chloride ions are found in solids or aqueous solutions in an ionic lattice. Chlorine is a covalent compound which is either found dissolved in the aqueous state or as a gas. So they do not have the same physical properties. Therefore, the correct option for this question is option C. Question 7. When substance Q melts, only weak forces of attraction between its molecules are overcome. Which row correctly describes Q? So if it has weak forces of attraction, it would have the least melting point or a very low melting point. So low melting points here include 44 and 98, which eliminates options C and D. And now the electrical conduction of solid Q. Since it has weak forces of attraction, it is a non-conductor. It cannot be a conductor. Therefore, the correct option for this question is option A. Question 8. A solution containing lead-2 ions is added to a solution containing iodide ions. A yellow precipitate is formed. What is the equation for the reaction that occurs? So we have got lead ions as Pb2 positive and we've got iodide ions as I negative. So Pb2 positive will react with two I negative ions producing PbI2, which is the yellow precipitate. So the first equation has 1 mole of iodide ions, which makes it incorrect. The second equation has a positive charge, a single positive charge for lead, which makes it incorrect. Same, the first equation also has a single positive charge for lead. The next equation has a two positive charge for lead, which is correct, but only a single iodide ion is reacting with it, which makes this incorrect. And the last equation has Pb2 positive reacting with 2I negative forming PbI2, which is the correct equation, making option D the correct option for this question. Question 9. Buckminster fullerene has the chemical formula of C60 and it is made up of 60 carbon atoms in the shape of a hollow sphere. Okay. How is the structure of Buckminster fullerene best described? A covalent compound, an ionic compound, a polymer, or molecular. So if it is made up of 60 carbon atoms, all forming covalent bonds, then it is a simple molecular compound. So covalent, ionic, and polymer are incorrect. Molecular is correct. And to be more specific, it should have been simple molecular, solid. So this makes option D the correct option for this question. Question 10. Which diagram correctly shows the arrangement of ions in the solid sodium chloride? In A, we have got a sodium atom surrounded on each side by a chloride ion. Therefore, there would be electrostatic attraction between them. In B, we've got a chloride ion to which there is a sodium atom on one side and chloride ion on two other sides. So this would not be attraction, this would be repulsion. So structure B is incorrect. C has got a sodium ion surrounded by further sodium ions, which is not possible because they would repel each other. And the same thing with chloride ions surrounded by chloride ions. So structure C is incorrect as well. Structure D has got the similar arrangement that would cause repulsion, a chloride ion attached to a chloride ion and a sodium ion attached to a sodium ion. So structure D is also incorrect. The only proper structure in which every cation is surrounded by anions and every anion is surrounded by cation is given in structure A, making A the correct option for this question.